As you probably already know, when we differentiate x to the n, we get n times x to the n minus 1. But why does this happen? Today, let's explore the reason behind it. First, let's define f of x as x to the n. The derivative of f of x, which is f prime of x, can be written using the definition of a derivative, right? Now let's substitute f of x equals x to the n into this definition. Then we obtain the following expression. If we try to take the limit as h approaches 0 in this form, we get this expression. But if we evaluate it directly, it becomes 0 over 0. This is an indeterminate form, so we need to rewrite the expression to eliminate this indeterminate form. To do that, let's expand the term x plus h to the n. Here we use the binomial theorem. If you're not familiar with the binomial theorem, I've explained it in a previous video, so please check that out first. I've included the link in the description. Using the binomial theorem, the numerator can be expanded like this. Now the x to the n and minus x to the n cancel each other out, leaving us with the remaining terms. So we can rewrite the expression in a simpler form. Notice that every term in the numerator now contains h. So we can cancel h in the numerator with the h in the denominator. This simplifies the expression like this. Now let's take the limit as h approaches 0. All terms that still include h will go to 0. As a result, f prime of x becomes nc 1 times x to the n minus 1. And since nc1 equals n, we get n times x to the n minus 1. Since we originally defined f of x as x to the n, we have shown that the derivative of x to the n is n times x to the n minus 1. Did that make sense? On this channel, we explore interesting math topics, problems, and fundamental concepts. If you enjoyed this video, please consider liking and subscribing.